All right, so for the review guide, so order of operation. Number one, yes, we do our exponent first. All right, so we bring down the 4 plus 24 divided by, and what is 2 cubed? 2 times 2 times 2, which is 8. So what's our next step? 24 divided by 8. But yes, you got the operation right. So 8 goes into 24 how many times? So 8 goes into 24 3 times. I know we're waking those brains up. And last step, 4 plus 3, 7. Excellent. All right, Zachary. Number 2 is 8 times 6 divided by 3 times 2. So order of operation tells us to do what here? Right. Yes, it's multiplication and division, so we just work left to right. So 8 times 6. 48 divided by 3. So 3 goes into 4 how many times? With 1 left over, so 3 goes into 18 how many times? There we go. Times 2. 32. Yep, perfect. All right, Isaiah, number 3. 3 times the absolute value of -4 plus 9. So what do we do first here? Right, so we treat the absolute value as a grouping symbol right now, solve inside of it. And so we have 3 absolute value. And what's -4 plus 9? 5. Right, so now what do we do? Right, this is multiplication. So I'm just going to go ahead and get rid of the absolute value because the absolute value of 5 is 5. And my answer is 15. Yes. All right, 4. Now this one has 3 times -4, the absolute value of -4, plus 3 times the absolute value of 9. Do you think we're going to get the same answer? It's 3 times -4 plus 9, the same as 3 times -4 plus 3 times 9. Oh, okay, no, we feel like it's not going to be the same. Okay. So Julian, what do we do first? So we have to get rid of the absolute value. So what is the absolute value of -4? So that becomes 3 times 4. And the absolute value of 9 is 9. So that's 3 times 9. So 3 times 4 is what? And 3 times 9. All right. And I'm just going to go work this out. 27 plus 12, 7 plus 2. Yes, 39. Very good. So yes, very different. More than half. All right, Zachary. Number 5 is yours. Own it. All right, so number 5 would be an excellent one to make sure that you work out and have good notes on. So 2 cubed plus 4 times 8 minus 3 divided by 18 minus 5 times 3 plus 4. All right, so I will get you started here. Remember to always separate this out. You need to simplify your numerator and then simplify your denominator. Then plug them back into a fraction and see if you can simplify again. So numerator is 2 cubed plus 4 times 8 minus 3. What do I do first here? Right, grouping symbol first. Can we go ahead and simplify the exponent? Yeah, doing it right now is not going to change our answer because it's not interacting with anything else yet. So 2 cubed is what, Zachary? 8 plus 4 times what? 5, yes. 8 minus 3 is 5. All right, so our numerator is 28. So let's go ahead and simplify our denominator. What do we do first over here? Sorry, when you're done writing. Now you're trying to do both. Okay. All right, so 3 plus 7 is 10. Now, do you want to leave this as a fraction or you want to turn it into a decimal? Sorry, my example did not give us a whole number or an integer as our answer. But I can either keep it as a fraction. It's up to you. You want to turn it to a decimal? Remember what any number divided by 10 is? Curious about 10. I feel like this was bugging me. I don't know where the 7 came from. That's supposed to be a 4. I think that's what happened. I went ahead and I don't know what I knew that it was 18 minus 15. And so I went ahead and did that and ended up writing 3 plus 4, which is 7, even though I was supposed to be writing 3 plus 4. So our denominator is 7. Okay, that makes a lot more sense. Because I was like, wait a minute, when I made these, I tried to make sure they all came out to whole numbers. Oh, come on, brain, wake up. All right, so Zachary, now we do have a whole number as our answer, which is what? 4. It's it's 4, yes. 7 goes into 28 4 times. Whew, okay. Oh, I love having things like that on recordings. That's okay. We all make mistakes, right? Especially your math teacher. All right. That coffee will kick in eventually. Okay, so Isaiah, next, number 6. I have 12 minus 3 plus 4. Just trying to see if y'all would catch it and you didn't. Very disappointed. Just trying to see that. All right, Isaiah, what do we need to do first here? I'm sorry, what? Did you say? Okay. So inside our parentheses, can we go ahead and do this one at the same time? Yeah, as long as we don't multiply them together before we do it, yeah, we can keep those same. So this is 12 minus, what's 3 plus 4? And 4 minus 3, right? Which is just, and 12 minus 7 is? Easy peasy. All right, Julian, last one. 15 times 6 minus 6 divided by 2. So what do I do first? You times 6 by 15. Can I also do the division part? Yeah, we can simplify both at the same time. So that one is 3. And what's 15 times 6? So 6 times 5 is 30. Carry my 3. Yep. Then it's 90. All right. What's 90 minus 3? Yeah. You meant 87. Yeah. Okay. All right. So everybody make sure you've got those on your notes. Not too bad, right? We good?
I got some here. Apart from the part where you know, did it wrong.
Apart from the part where I wrote the answer instead of the part of the problem. That's an ADD issue. My brain is moving at a different speed than my hands. Definitely. At a different speed than my, yeah. Once I finish my coffee, my brain should calm down a little bit. Okay. And it does for me, I'm afraid. Yes, coffee calms me down. All right, so scientific notation, we just worked on last Friday. So in 8 and 9, we are writing the missing exponent. In 10 and 11, we're writing the exponential form, or excuse me, the standard notation, scientific notation in standard form. So let's go ahead and start with those. So am I back to you, Zachary? I think so. So this one we have 0. How many are there? 4, 1, 2, 3, 4, 737 equals in scientific notation, 7.37 times 10 to the power of what, Zachary?
To the power of 5.
1, 2, 3, 4, 5. So 5. Is the original number smaller than 1 or larger? There we go. Uh-huh. I just didn't hear it. You said it in your head. So yes. Okay. Here's the thing. You have to, because there's two very different things. So all you have to do is, that is not what I wanted. If your original number is a decimal, then your exponent is going to be negative every time. If you're having to move the decimal place to make a whole number, a whole number larger than 1, then you must have a negative exponent. All right, Isaiah number 9, we have 1,382.4 equals 1.3824 times 10 to what power? The third power. So we already have a decimal place, so we're just moving it 3 places to the left. And we have a number in the thousands, 1,382.4. So our exponent must be positive. All right, Julian. So in this, we need to write it in standard form. So we have 3.75 times 10 to the negative 3. So that negative exponent means what, Julian? Is this number? We're moving our decimal to the left. Yes, we're going to make a smaller number. So how many times are we moving it? So 1, 2, 3. So what's my final answer? 0. So you have 2 zeros after the decimal?
Oh, yeah.
So 2 zeros after the decimal. You should.
Oh, yeah, well, I do.
Are you think you're second guessing yourself? Why?
Like, yes, that question, I'm like, oh,
I ask it when y'all are right, when y'all are wrong, because I want you to understand the concepts. I don't want you, as much as we possibly can. Okay, I cannot get this thing. Oh my gosh. I'm trying to move my screen and I can't because it's being difficult. I can try to scooch in. Okay, apparently that's all I can do. There we go. Okay, so this is correct. Just move your decimal 1, 2, 3 to the left and you're good. All right, Zachary. Write 0.2 times 10 to the 5th power in standard notation?
It's 800,000.
Yeah, we had 1, and then you're gonna have 4 zeros after it, which you have, and so that is correct. Mhm. Isaiah, write 0.0703 in scientific notation. What is my factor? 7.03, and then times 10. Is my exponent gonna be negative or positive? Are you sure? Is my original number less than 1 or greater than 1? Yeah. Uh-huh. Y'all do that a lot. It's okay. Just, that's why I'm trying to work on the concept, because if you know what to look for, then it makes it easier to figure out if you're doing it right or not. So as long as that original number is less than 1, you have a negative exponent. I'm gonna show y'all something when we finish this to see if it helps as well. Or Mike can put it in your notes. All right, so, but negative what? -2, 1, 2, that's where we put it in our factor. So yes, we have 7.03 times 10 to the negative. All right, good job. Julian. 0. Oh my goodness. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 3, 2. So what's my factor? That's my exponent, I think. What's the first part though? 3.2, perfect, times 10, and you said 10 to the -7? 1, 2, 3, 4, 5, 6, 7. You are absolutely right, sir. Very good. 3.2 times 10 to the -7. Oh, it's not gonna move again. Okay. I'm sorry, I'm numbering these. I'm supposed to be doing them by letters. So this is actually let's see. This one's actually A. This one is B. Okay, so C is 4,209,000 in scientific notation. Zachary, what's my factor? Yes, this is our decimal. 1, 2, 3, 4, 5, 6. So 4.209 times 10 to the 6th power. Excellent. All right, last one for this section, Isaiah. 34,872 in scientific notation, please. Mm-hmm. Yes, times 10 to the 4th power. Good job. Y'all got this? We're pretty good. Okay. Something to write. You can write this on the back if you want, and then we'll get to number 13. But I want us to look at this. All right, I'm just gonna, okay, so I'm just gonna use 10 as our base number. So if you have 10 to the power of 0, what does that equal? 1. All right, what about 10 to the power of 1? 10, because there's 110. Because that's 10 not being multiplied by anything. What about 10 to the power of 2? Just add a 0, right? 10 to the power of 3? 1,000. All right. Now, what's the next number smaller than 0? Okay, so if I have 10 to the power of -1, what is that? Nope. It's not negative. Nope. Anybody want to help him out? What's 10 to the power of -1? One. It's in the tenths place. And see how 10 to the power of 1 is 10, 10 to the power of -1 is 10th. Which means that 10 to the power of -2 is what? That's our 0.01. So again, you'll notice 10 to the power, 10 squared is 100. 10 to the -2 is the 100th. Right, when you think about place values. So 10 does make this easier, but I'm trying to kind of help you guys with your negative exponent. So that means that 10 to the power of -3 is what? Yes, the 1,000th. All right, so when you see a number where the digits that have value are behind your decimal place, then you are looking at a negative exponent. Or you have to make the number smaller. So that's super important. All right, so let's make sure y'all got that. Let's look at number 13. Okay, so we are putting these in order from greatest to least. So we're using the greater than symbol. And I gave y'all some space here because you're I would go ahead and put these in standard notation and then write the scientific notation in order. Because these are not technically in scientific notation. Obviously 22 is larger than 10. So, and 2,270 is much larger than 10. So these are not fully in scientific notation. 2.27, this one is 2.27 times 10 to the power of 0. 0.227 times 10 to the power of 5. All right, so Julian, what is 22.7 times 10 to the 4th? What is that in scientific notation? That first number there. You tell me, left or right? To the right. So 2, 2, 7 is 1. 0 is 2, 0 is 3, 0 is 4. So what's that number? 22. There we go. All right, Zachary, 2,270 times 10 to the power of -2. What's that number? Remember, -2 means you're making that number smaller. There we go. Very good. All right, Isaiah, what about the next one? 2.27 times 10 to the power of 0. Perfect. Trick question. All right, last one, Julian. 0.227 times 10 to the power of 5. So it's going to get smaller? Yeah, it's got to get bigger. Yeah, so we're moving the desk 2, 2, 3, and then we just add how many more zeros? Yeah, 1, 2, 3, 4, 5. So 22,700. All right, so now let's put them in order. Zachary, what's my greatest? What's my largest one here? 22.7 times 10 to the power of 4. Isaiah, what's my next largest? Okay, so give me that in Right, 227 thousandths, or yeah, 227 thousandths times 10 to the fifth. All right, Julian. What's my next largest? The 2,270 times 10 to the negative 2. It's this one, right? Because we got that one, we got that one. Now we're at 22.7. And so Zachary, that means my last one is what? There you go. There we go. Too quick. It's like I can write it on paper, but saying it out loud becomes very different. All right, that's our review guide. So, if you understand all of that, you should be in pretty good shape for the quiz. There is. Let's see here, 3.28 times 10 to the power of 5 and 3.28 times 10 to the power of negative 5. Which one is the bigger number? This one is bigger. Are they close? No, they are extremely, vastly different numbers. That is our largest. So yeah, this is 328,000. So 328,000. This one is so much less than 1 that it's almost 0. 1, 1, 2, 3, 4, 3. Every time. 2, 8, right? 1, 2, 3, 4, 5. Yep. All right. That's all. Let me go ahead and stop my recording here.